Good day, viewers. You're welcome to Sir X channel. And today's class, we'll be looking at how to evaluate limits by direct substitution. So, in our previous class, we've made mention of the methods of evaluating limits, and one of which is by direct substitution. In direct substitution, all you need to do, just as the name implies, is to substitute the value for which your function approaches, and then boom, you have your answer. But in cases where it fails, what are actually the cases where it fails? When we encounter indeterminates of any forms, maybe the form of infinity divided by infinity, infinity minus infinity, 1 raised to the power of infinity. You can have 0 times infinity. All of those are indeterminates. So when we encounter those forms, then we know that our direct substitution does not work. But let's see how we evaluate limits using direct substitution. So join me. Okay, so to evaluate this limit using substitution method, all we need to do, because it says the limit of x plus 2 divided by x squared plus 5x plus 6 as x approaches 2. So all we need to do is to substitute x for 2 because x approaches 2, right? Okay, so this becomes x plus 2, x squared plus 5x plus 6. So this will be 2 plus 2 divided by, this is x squared, so we have 2 squared plus 5 times 2 plus 6, right? And so we simplify. This will be equal to 2 plus 2, 4, divided by 2 squared is 2, 2 squared is 4 rather, so we have 4, plus 5 times 2 is 10, plus 6, and then finally we have 4 divided by 20. Okay, so this is the answer to the question. So this is how you evaluate limits by direct substitution. How about what we have on the other side of the board? Let's see how we do that. So for the limit of 8 multiplied by t minus 5, t minus 7 as x approaches 6. So let's see how that works, right? So this will be equal to 8 into 6 minus 5. So in place of t, you put 6, right? Because t approaches 6. And this becomes 6 minus 7, right? Okay, simplifying further, this becomes 8. 6 minus 5 is what? 1. And 6 minus 7 is what? Minus 1. So you take the products of what you have at hand, and then you get minus 8, because 8 times 1 is 8, and 8 times minus 1 is minus 8. So that's the solution to the question on the board. Okay, so we may want to take 2 more examples so as to solidify the fact that our understanding was actually productive. So we want to take 2 more examples. Example, for number 3, I would like us to evaluate this, a case where we have special function. Okay, so this is the limit as x approaches pi for sine x plus e raised to the power of x divided by x. So in this particular question, we have special functions which are sine x and e raised to the power of x. So let's see how we evaluate the limit. Okay, so it means for x, I will put pi because x approaches pi, right? Okay, so I have sine of pi plus e raised to the power of pi divided by pi. Guess, sine pi is equal to 0 because pi is 180, right? So sine of 180 is equal to 0. You can check it out in your calculator. So this is 0 plus e raised to the power of pi, which is still the same thing as e raised to the power of pi. So this is e raised to the power of pi divided by pi. And that's the answer to that question. How about we see one more? This. So we have something like this. The limit as x approaches 0 for e raised to the power of x squared plus x. I'm guessing that you know what that means already. You know the answer, but let's walk through it together. So for this, we have x approaches 0. So in place where we see x, we'll just substitute 0, right? Okay, let's do it. So this becomes e raised to the power of 0 squared plus 0. Of course, 0 squared is 0, right? So we have this to be equal to e raised to the power of 0. 0 plus 0 is 0. So this becomes e raised to the power of 0. Yeah, and that will be equal to 1 from our law of indices. Anything raised to the power of 0 is equal to 1 except 0 raised to the power of 0, right? So that's equal to 1. So this is how we evaluate limits using direct substitution. Remember, if by substituting you get any form of the indeterminate that I've mentioned, let me list those out for us again. You encounter something like this: 1 raised to the power of infinity, infinity minus infinity, infinity divided by infinity, 0 times infinity, 0 divided by 0. Is there any more? This is 2, this is 4, this is 5. So any of these forms of indeterminate, if you encounter them after plugging, then know that you cannot actually resolve that question by direct substitution. Those are pitfalls. So this is how we evaluate limits using direct substitution. So up until I come your way again, don't forget to like, subscribe, and then click on the notification button so that you can get to see my videos when next they are uploaded. Thank you.